Hi, welcome to the fourth section, Multi-Thread and Distributed Computing with Gearman. In this section, we will start with Introduction to PHP Parser Library. Lastly, we'll see Introduction to Gearman. Now we move on to the first video of this section that deals with Introduction to the PHP Parser Library. In this video, we're going to take a look at using PHP Parser Library. We will also see implementing the PHP Parser Operator. The PHP Parser is a library that takes a source code written in PHP. It passes through a lexical analyzer and creates its respective syntax tree. It is very useful for static code analysis, where we want to check our own code not only for syntactic errors, but also for satisfying certain quality criteria. We will write an application that takes a directory, iterates all its files and subdirectories recursively, and runs each PHP file through the PHP parser. We will check only for one specific pattern. Now let's look at the code to find any statement where we use the assignment inside a condition. Here is our code example. When your application is not behaving as you expect, and you don't know how you might spot any of the examples, then you would not be able to say at first sight whether this is intentional or you are just missing one equal sign. Maybe you wanted to write a condition such as if a is double equal to 1, and you just forgot 1 equal 2. This can be easily spotted and reported by the static code analyzer. So let's start by first trying the PHP Parser library itself and then wrap it with the PHP operator. Before we start, we need to install the PHP Parser library. We use Composer to install the PHP Parser. As you can, it is successfully installed. Let's see another code example. We are going to analyze and process the code with the parser. Here we are getting contents of file. We run it. As you can see, the output is very long nested tree structure representing the code we passed to the parser. We can see that the if statement has a property called cond that contains the parsed condition, which is an instance of expr assign object. All the statements we are going to test have the cond property, so testing whether they contain an assignment in condition is going to be relatively simple. The only exception is the for loop, where the condition might have multiple expressions separated by the comma character. The syntax tree is a nested structure that we need some way to iterate it recursively. Fortunately, it is supported by the library out of the box via the node traverser class and by registering custom visitors. Visitors are classes with multiple callbacks that are called when the tree transverser starts or ends processing the entire tree or enters or leaves a single node. Let's take a look at the code which will be part of the custom operator. As you can see, we're checking each node type with multiple instances of statements and their respective cond properties. With the for statement, we need to check the array of the cond statements, but the rest is analogous. Every time we spot our tested style check, we just print the line number. Let's run the code. We can see that the line numbers really match the source file we presented. As we can see, if statement is on third line, we get 3 here. Next, else if is on 5th, while is on 6th, and for is on 7th line, and we get same in the output. Now we see the code example for implementing PHP Parser Operator. If we want to process multiple files, then we just run the parser multiple times. But what if we want to have better control over what files are going in, or we want to make the pre-configured parser with our custom node visitor easily embeddable into any PHP application? Let's assume we want to use the PHP Parser library. We have a typical PHP chain of operators where we lift PHP Parser Operator. This class takes in its constructor an array of classes that will be added as node visitors to its internal node traverser. As an input, we are using a primitive array of file names that will be emitted by the source observable. The observer will then receive just an array of code style violations reported by each of the visitor classes. Since we want to be able to add any number of custom node visitors that can check anything they want, we need to be able to collect all their results and re-emit them as a single value by PHP Parser Operator. We start with redefining an interface that all our node visitors have to implement. Our interface is Observable Node Visitor Interface. The one requirement for a node visitor is to return an observable where it'll emit all code style violations. Now let's see assignment condition node visitor code. The node visitor uses a subject internally. In the emit next method, it emits every code style violation as a single item. This item is an associative array itself that contains the line number and the well-formatted expression that caused the violation. The pretty printer class is a part of the PHP Parser library. The subject class also needs to emit a complete signal when we're done with the syntax tree. That's in the after-traverse method. We call the complete signal, which is very important to let other operators work with this subject properly. Since we need to expose the subject, we need to make sure that nobody else can manipulate with it, so we wrap it, using the as observable operator. The PHP Parser Operator will hold a single reference to the PHP parser that we will invoke for every file that comes to the operator. It also means that we need to create a new instance of the Node Traverser class for each file and add new instances of each custom node visitor to it. From the operator's point of view, all node visitors are just observables that emit style violations. The operator needs to collect all values from all of them and then re-emit this collection as a single item. Now we split the example into two smaller chunks. First, we'll have to look at the creation of the node traverser instances filled with node visitors. We keep an array of class names for node visitors in the traverser class's property. The create traverser method, when we want to create a new node traverser, we iterate this array with the array map function and instantiate each class. Then we not only add it to the traverser, but we also take its observable and chain it with the toArray and map operators. The toArray operator collects all items emitted by the source observable and re-emits them as a single array when the source completes. This is why we had to be sure we properly called complete in the assignment and condition node visitor class. We also use map operator to emit the final collection of violations with the class name that generated them. The create traverser method returns two values, the node traverser instance and an array of observables returned from each node visitor. Now let's see the rest of PHP Parser Operator. In this part of PHP Parser Operator, where the actual subscription happens, first of all, we are using callback observer, which just passed through all error and complete signals. The interesting things happen only in the anonymous function on next. First, we are expecting each item to be a string representing a file path. We read the content of the file with the file get contents function to get the source code we want to analyze. Then, we call create traverser function, which returns a new instance of node traverser and also an array of observables, where we'll get all the style violations. These are already wrapped with toArray and map operator. We are creating a new fork join observable and passing it to the array of observables. The fork join observable class subscribes to all its source observables and remembers only the latest value emitted by each one of them. When all the source observables are complete, it re-emits all the values as a single array. We know all the sources will emit just one value and then complete. We are not interested in node visitors that didn't emit any violations, so we remove them from the result in the map operator. In the end, we just subscribe the observer itself to this chain. We are purposely not using just subscribe observer because this would re-emit everything including errors and complete signals. The same reasons apply here as well. After all this, we just run the traverse method that analyzes the source code and will emit all violations that will be gathered in fork join observable. This was a pretty complex operator with a sophisticated behavior. Now we go back to the example where we showed how we want to use this operator. We can see that all this logic is effectively hidden from us. Let's run it. As you can see, we have obtained the output. Each item coming from this operator is a series of nested arrays. We can see the file name we analyzed and the array of results, where each item is generated by one node visitor. Since we have just one result, we also have just one array here. Each result is marked by the node visitor class name and a list of violations. Each violation contains the line number and the exact expression where it occurred. Symfony 3 has over 3,200 files. If processing a single file would take just 1 millisecond, then analyzing the entire project would take over 3 seconds. In this video, we have learned Introduction to the PHP Parser Library.